Hello student, I am Arnab Das. Today we discuss about the sinusoidal oscillator. An oscillator is a device which generate a alternating voltage. That it means it is a AC output generator, and the circuit which generate an AC output signal without requiring any external applied input signal. So an important point is that for the oscillator is here to produce the AC output, no input signal you have to record. The oscillator convert DC energy into of AC energy. Means that here it is can be represented. This is a converter which convert the DC energy into the form of AC energy. So the function of a oscillator is opposite to that of a rectifier, because we know that for a rectifier AC power is converted into the DC form. The function of a oscillator circuit is similar to that of a amplifier circuit, but there obviously some difference is present. What are they? First one is that for the amplifier their input should have to provide, and that particular input, as I say, this is coming as the input for the amplifier, this one, and amplified output will be, say, this is come as such. So here amplification is done due to the reason of DC input power, and that output waveform formation will be depend on the what kind of input you are applying or providing for that particular amplifier. But for the oscillator one, there no input signal is applied. That is, here no input is applied on there. In the internal circuit of the oscillator, there the passive or active element which are present, they are generate or they are the ultimate reason for the output waveform. As you see, this is the sinusoidal one. And to make the value as a constant one as the output waveform, that the DC power input you should have to provide. That means here output waveform is due to the reason of the oscillator internal circuit diagram, not the reason for the input signal. If you want to change the frequency, that time should be the oscillator internal circuit, you should be changed on there. That means for the modification can be occurred by only the reason of oscillator internal circuit diagram on there. Now for example, we already told there's some written version is given to you, and if you read just for a single time, so it will be easy for memorize also to you. The amplifier take energy from DC power source and convert it into a AC energy at a single frequency. In an amplifier circuit, frequency, waveform and magnitude of AC power generated is controlled by the AC signal voltage applied at the input of the amplifier. So, which I already told you that the waveform which will become at the output side, it will be totally depend on what kind of waveform you are applying at the input for the amplifier. There only the amplified version will be reason for the DC input. That is the energy will be provided or power will be provided to the input signal for amplifying by using the DC power input. On the other hand, in an oscillator, the frequency, waveform, and the magnitude of the AC power generated is controlled by the circuit itself. That is, internally it is built it on there. No external controlling voltage is required. In oscillator, the frequency of the output is determined by the passive component used in the circuit and can be varied at will. So if you want to change the oscillation as a frequency, that time it is sufficient to change the passive component which is present for the oscillator. Thus, an oscillator may be considered as the amplifier with provided its own input signal. An alternator, there are difference also create with the alternator one also, which is a AC generating machine. That means a AC signal generator can also treat for an example for alternator. It can be used to generate frequency up to 1000 Hz. To generate the high frequency, either the number of pole has to be made large or speed of the rotation of the armature to have to be made extremely high. Both condition or both criteria is impractical. That is, you cannot be increase as a value of some limitation. After that you cannot be increased. So pole will be after a certain distance will be limited one, and the speed also armature you cannot be rotate the armature after a certain limit. So there frequency generation it also bounded on there for the alternator. Hence the alternator cannot be called as a oscillator. Following at the difference between the alternator and oscillator also, that is, alternator is a mechanical device having a rotating part, but obviously for the oscillator they are non-rotating electronics device. Alternator convert mechanical energy into the AC energy, but oscillator convert DC energy into the AC energy form. An alternator cannot produce high frequency, already told that, because we are not able to modify the pole number and also cannot be increase the armature rotation speed after a certain limit. So there the production of high oscillation cannot be done by the alternator. So oscillator can be applicable from the few hertz to several megahertz of frequency generation. Now we are talking about the type of oscillator. According to the nature of the generation waveform, that means what kind of formation of oscillating frequency that particular oscillator can generate, on that point of view it is classified. If it is a sinusoidal form signal is generated, that time this will be defined as a sinusoidal or harmonic oscillator. If it is generate a non-sinusoidal oscillator, also named as a relaxation oscillator, will be defined the another kind of oscillator. And the typical example for the relaxation oscillator are as a square waveform generator, triangular waveform generator, pulse or sawtooth waveform. That means this kind of thing. If it is the square signal, for the triangular signal, for the sawtooth signal, it will be look like this. For the sawtooth signal, uh, it will be as such. This will be sawtooth waveform. So this kind of are the example for the relaxation oscillator. Another way also it can classify it, that is what frequency it can generate. If it is as a audio range, that is it is within the few hertz to 20 kilohertz, that time this is the audio frequency oscillator. If it is higher than the value of 20 kilohertz, that time that kind of oscillator will be named as a radio frequency oscillator. So here various kind of oscillator can be classified for the radio frequency, which is as a very high frequency oscillator. If it is frequency generate from the 30 megahertz to up to 300 megahertz, for the 300 to 3 gigahertz it will be defined as a ultra high frequency. In such a way they are classified. Sinusoidal oscillator may be further subdivided, that is the sinusoidal signal generator can be classified into the form of the tuned circuit or LC feedback oscillator, RC phase shift oscillator, negative resistance oscillator, and the crystal oscillator one on there. For the LC feedback oscillator is used to generate the frequency. Their example is tuned collector, Hartley culprit, etc. For the RC phase shift oscillator, their RC network is used to generate the oscillation process. The example are phase shift oscillator, wind bridge oscillator, negative resistance oscillator, where the negative resistance property is used on there, and the example is tuned diode oscillator. And for the crystal oscillator, here they replace the LC circuit by using the piezoelectric crystal. So this is the broadly classification for the oscillator. Now we are talking about how the oscillation process by using the tank circuit or the LC circuit is created on there. If you consider the first one picture, as you say figure number 2a, for the 2a, here the capacitor and inductor is connected into the parallel form. Within that there a switch is present. Initially we just think that the capacitor is fully charged, and we know that capacitor store the energy in electrical field and inductor store energy in its magnetic field. So on that point of view, we say that here capacitor, due to the reason of this, is a fully charged. Here electric field is stored on there. When switch is on, that is picture or figure number B, when the switch is on, due to that reason electric field is stored on there, the electron concentration below this plate will be high, and that is try to complete the path after the switch on. But due to the reason of L or inductor, they are not complete so easily. That means here electrical energy is now transferred into the form of magnetic field, and the inductor property is that they are trying to oppose their state by flowing the opposite direction of current. So here the maximum current will be occur when the capacitor is fully discharged. When it is fully discharged, that time total electric field will be come or convert into the form of magnetic field at the inductor. Now inductor continue to refuse that one, and for this reason, for the picture C or figure number C, here what happened, the capacitor is now the upper side plate will be concentration of electron is high and lower side concentration of hole is high at the lower plate. That is, it is reverse is occurring there for the figure A. So again, due to the reason of this switch is on, closed path is present, it will be again there the electric field which will be transferred at the inductor as a form of the magnetic field, and magnetic field again it is tried to oppose, and there and current will be produced with the opposite direction. So there a current will be flow, or there a magnetic and electric field will be toggle each other, so there an oscillation process will be goes on there. So I think each and everyone able to understand what is the way by which LC circuit can be used for generating the oscillating frequency. So next day we will discuss this kind of LC circuit how can be implement for generate the frequency one also. And again in here, just for a conclusion, we can say that the frequency will be depend on the value of L and C. If you know the value of L and C, that time the generated frequency will be 1 by 2 pi root over of LC, and which is written as a form of this one. Look that the generated frequency will be F0, which is 1 by 2 pi root over of LC. But this is for the practical case, because ideally here happened that for the inductor and capacitor no power consumption is occurred, but in practically they are not as such. Their power consumption is occur for the L and also the C. So their initial the oscillation process, it will be after a certain time, it will be as a decaying form. That is, the output waveform for the oscillator will be as a damping one form. That is, a slope will be created on there. And after a certain time, there no output or oscillating signal will be come out on there. To maintain the frequency with the same amplitude, there should be supply a DC source to maintain the frequency, maintain the amplitude as the same manner. Okay, and for this reason, this is a DC power source you have to apply as a input on there. But to generate the AC signal, no internal AC or alternating voltage you should be applied on there for the oscillator one. So I think each and everyone can able to understand what is the reason by which the LC circuit will be work as the oscillator one, and why we should apply the DC source for the oscillator circuit. And next day, as I say, we will discuss about LC circuit how can be implement to generate the oscillation circuit or oscillator circuit. Till I have to say bye, stay well and good. and thank you.